All right, we're here at the 2024 Automate, and we're at the Shunk booth. Here I have Aaron with me, who's going to explain a little bit about what Shunk does and what this particular system is doing, and some of the different Shunk components that are within this system to kind of show you guys how Shunk may fall into some of the applications that you may be working on or working with inside your manufacturing facility. Aaron, thanks for joining us today.
Yeah, thanks Malachi. So I'm Aaron Royster. I'm one of the product managers with Shunk out of the North Carolina office. So here at Automate this year, we're really focusing on machine tending, assembly applications, and also some secondary tasks as we develop, some deeper automation integration. So yeah, we're excited to be here, and it's been a great show so far.
Awesome.
So what we see behind us is kind of a combination of a lot of different technologies. So we see, of course, some FANUC SCARE robots, and we're picking and placing some battery cells. And the reason we showed this as a solution is we're seeing with the internal combustion shift over to EV, round cell handling of various sizes has become an application focus for a lot of integrators.
Yep.
So we want to show the fast, precise pick and place options that are available. So we see gripping, both parallel and centric gripping. We have some linear motion from Schunk that's driven by FANUC motors. We have some Z-axis added here with Shunk's pneumatic linear technology. So there's a lot of components that are being paired together here for a total solution.
Yeah. So for those of you who don't know, Shunk is very much like a work holding type of company. Do a lot of work holding, tool changing, those type of grippers and types of components or hardware.
Absolutely. So Malachi, great. Our kind of divisions are broken up into tool holding components, work holding components, both rotating and stationary, as well as the automation technology. So Shunk got our start in industrial manufacturing and work holding equipment, and then that translated into the automation equipment that we see here at Automate today.
Gotcha. Very nice. Yeah, and to point out some really cool things about this system is, it really showcases some different ways to go about, developing a system and maybe even some things that might reduce the cost of the system. Like, for example, like how they're using like the cylinder here for this Z actuation. This is, if you see these two platforms are at the same level, but that one just raised up so they can pass each other in that way. But instead of having another servo driven Z axis, which would, increase the cost by quite a bit, you can use something like this that has a little bit lower cost to it. Is this electric or is it pneumatic?
That's pneumatic off-the-shelf component. Yes, sir.
Yeah, pneumatic off-the-shelf component. There you go. So you was able to perform that Z motion and do a transfer between the two by utilizing this piece of hardware. They also have the FANUC motors that are paired with their mechanical linear rail units here. So this is giving you the ability to have like FANUC controls and it's with the linear rail type of system. And these FANUC controls here, these ones in particular are set up with their own separate controller. It's probably the CNC controller, but it could also be set up to be paired with one of the robots, where one of the robots is actually the master of these servos as well. And then that gives you the ability for this robot to know exactly where these are at in space, and you can do that with the CNC or robot controlled versions. But this will give you the ability to know where they're at in space. You can also do like equipment safety checks. You can do like DCS zoning. So you can put basically safety boxes around these. So that way, if somebody was to enter into that space, maybe at a light curtain right here instead, that these can't move if like that light curtain is broken. And same thing with that rotary table back there. This is also a mechanical Shunk unit, right? And it's also driven by a FANUC servo motor as well. And so they're able to get that rotary feedback and know exactly where that rotary table is at all times. Awesome. And then these grippers that you're using here on the robots, these are electronic grippers, right?
They are, yes sir. So that's called our EGP. It's a very simple electric actuator. It's digital I/O controlled. The nice thing about when you know your workpiece dimension is you don't have to worry about flexibility. That's kind of a trend lately in automation, is people want additional strokes so that they can grip varying workpieces.
Yep.
But in this example where you're doing the same thing over and over, a digital I/O simple mechanical gripper with a servo drive, it's just open close. So that's why it's a great option for a high-speed pick-and-place application like this.
Gotcha. So this particular unit right here, it's like non-servo, it's just open and close, or it is servo?
I think it is still servo-driven, but it's just digital I/O controlled, so you can't go to a certain position. It either goes to its home position and open, or full close.
Gotcha.
Yep.
And these are probably working on a 24-volt signal?
Yes, sir. That's correct.
Yep. Okay. And then these other ones back here are pneumatic. So you have the option to get a lot of their grippers in an electric version as well as a pneumatic version as well.
Absolutely, and we call these alternative products, the EGP that you see here, because in a traditional manufacturer, if they're running a lot of pneumatic vices, they want to go electric because they want to get rid of compressed air or the noise, or they just want to, you know, save some energy. We call this alternative because it does effectively the same thing, but it's instead of pneumatic, it's an electric alternative. So in the back is mostly Centric 3-jaw grippers that are all pneumatic, but yeah.
Very good. Well, thank you for showing us this system, and we're going to go ahead and make a move to the next one.